We are looking at page 3, and we are looking at something called molarity. I actually stole some definitions from page 2, and our definition of molarity is moles of solute over liters of solution. So what's solute, what's solution, what's solvent? We should probably know these things as well. So solute is a substance that gets dissolved. Solvent is a substance that does the dissolving. And then the solution would be the combination of solute and solvent. So let's say I am making a saltwater solution. The solute gets dissolved. The solvent would be the water. And then the whole thing, um, the salt water would be the solution. So we have something called molarity. I think I'm just going to scroll here because we can calculate different molarities here. So I'm just going to slide this up a little bit. And we have molarity is moles. Its symbol is big M, and it's moles of solute over liters of solution. So how would that work? Let's say I had a 1 liter beaker. Okay, so this is a 1 liter beaker. And if I put in 1 mole, it would be a 1 mole per liter solution. If I put 2 moles in this 1 liter, it would be a 2 molarity solution. Notice 2 molarity is twice as strong or twice as concentrated as 1 molarity. Now, usually you don't stuff moles in a liter, but we might make solutions with sodium chloride in water. So if I put 1 mole of salt, which would be like 58 grams of salt in here, that would be, and filled it up with water to the 1 liter mark, that would be a 1 molarity solution. I could double the concentration of this and make it 2 moles in 1 liter. I wouldn't really have the container in there. I'd put water in there up to the 1 liter mark, and then I would dissolve that in there. So that would be a 2 molarity solution. And a 2 molarity solution would have twice as many moles in the same volume as a 1 molarity solution, so it would be twice as concentrated. Let's look at how to do molarity calculations. So this one says, what is the molarity of a solution containing 0.20 moles of NaCl in 400 milliliters of solution? So I can go right to my definition. Molarity, where the big M equals moles of solute over liters of solution. So what I'm going to do is say molarity here, and that's going to equal, oh, do I know my moles? I think so. It says 0.20 moles. So I'm going to say molarity equals moles. It's already given. I don't have to do anything with that. So I'm going to say 0.20. Whoops, that doesn't look very good. Moles. And then I got to divide it by the number of liters. Oh, well, I'm given milliliters. Now, way back at the beginning of the year, we said there was 1,000 milliliters in 1 liter, or one big L, which is a liter. So a couple ways you could do this. You could say 400 divided by 1,000 leaves me with 0.4, or you could just take this 400 and slide the decimal 1, 2, 3 places and say that's going to be 0.4. So I'm going to call this 0.4, or I'll say 0.400 liters. And I put that in my calculator, 0.2 divided by 0.4, and that's going to equal, say 0.50, and I'm going to put a big M for molarity. So that's how many moles there would be per 1 liter. The more moles you have, the higher the molarity will be, but the less space you crowd it into those moles. If you crowd it into a bigger space, it's going to be less molarity. If you crowd it into a smaller place, then that's going to increase the molarity. So it ends up being moles divided by liters is molarity, and it looks like we have a 0.50 molarity solution right here. Okay, one more example of this is, what is the concentration of a 500 milliliter solution containing 52 grams of LIF. So again, I'm going to do molarity formula. Molarity equals, and I'm going to put, oh, I'm given grams. I might have to do a little work to find that. I'm going to do my moles. I'm going to take care of that first. So I'm going to do a little line here. And I'm going to take care of my, I'm going to take care of my liters. 500 milliliters, I'm going to slide my decimal 1, 2, 3 spots and call that 0.500 liters. Okay, or I might just put a 0.500 and I'm going to put a liters there. But I got to figure out moles. Well, if I know grams and I know the molar mass, I can just take what? Grams divided by the molar mass. So I'm going to kind of do that up here. Change the color here if I did that right. And I'll go right over here. I'm going to go 52 grams. And then I'm going to say times 1 mole over divided by 26 grams. And again, or you can just do 52 divided by 6, and that's going to equal 2.0 moles. And I think I'm going to crowd into my stuff here. I did. But I think we can see that 52 divided by 26, 52 divided by 26 leaves me with 2 moles. So I convert my grams to moles. Now I can go back over here and take that. Let's change that here. Come back here. I'm going to take this 2 that I got here and call this 2.0 moles. How did I know that was 2.0 moles? I took 52 divided by the molar mass, kind of pre-did that, equals 52 divided by 26 is 2 moles. And then 2 divided by 0.5. No, what's 2 divided by 0.5? I think that equals 4.0. We'll do it like this. And then I'll put the big M for molarity. So again, these are 2 different substances, but 4 molarity solution would be more concentrated than a 0.50 molarity solution. The bigger the number in front of the M, the more concentrated it is. The smaller the number in front of the M, the more dilute it is. So that is an example of finding molarity, sometimes framed as finding the concentration, because that's how we measure concentration in molarity, for page number 3, type A problem. Thanks for watching.